Good afternoon, everyone. Hello, how are you doing? Hope you're doing well. Hello, 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 and hello. We have a Darwin Evo. This is still the OG one. It will be hopefully going to America soonish. Obviously, arranging shipping is a somewhat complicated process for such a large machine, but we are in progress. I can't run it today because I've already switched out for a 110 volt bed. So obviously can't put that on 230 volts because that would be problems. How is everyone doing? Hopefully good. So, the plan for today is not particularly to do anything, really. We're just going to be... It's basically an opportunity to talk about the BOM and for anyone to ask questions. So there's a link down below which gives you access, hopefully, to the public BOM. It doesn't have the full BOM costing and everything. It's basically a category, a name, a BOM quantity, where to buy, with a link. Hopefully that's enough for everyone to actually buy the things that they need. Oh dear. My formatting is a little bit weird, but let's not concentrate on that too much. So, to answer the question, what is Darwin? I'll do my best to do this off the cuff. So Darwin was basically the first publicly available RepRap 3D printer, which is to say a printer whose objective was to manufacture a significant proportion of its own parts. So a rapid prototyping, self-replicating machine, which of course was part of the RepRap project, which was Adrian Bowyer and Ed Sells back in the early mid-2000s-ish. Obviously, the project was a number of years. The actual specific public release date, I believe, for the very first Darwin machine was tomorrow, 20 years ago. Is that right? 2004. Bloomin' hell, that was a long time ago. It makes me feel old. So yes, it's not... Darwin is not a new machine. Darwin Evo is designed to look like the very first Darwin that ever existed, but using a whole bunch of modern parts. So we've got like Big Tree Tech at Modern Electronics. We have a modern Raspberry Pi, Raspberry Pi 4. A nice power supply, mains powered bed, goes up to 100 and something degrees, although it's not enclosed, so ABS is probably not something you probably want to be doing much. We've changed a bunch of the design things. We have like a stealth burner on the front here. We have a Nomi screen, again by Big Tree Tech. Clockwork 2 extruder. We've got a tool head board with CAN bus. So basically a whole bunch of modern stuff. Mainly the modern stuff revolves around being electronics, with the aesthetics and design of about 20 years ago. And this first machine, well, I only ever really designed it to be a one-off. So I created it for Smurf, the Sanjay Mortimer RepRap Festival, so we could auction it off for the Sanjay Mortimer Foundation. So that was kind of all said and done. We did that. We've done the auction. It was won by Ellie Weinstein. I'm presuming that's how you pronounce her last name. I can't remember the amount it went for now. £2,650, I think. Which I was extremely happy with. So this machine will be going that direction soonish. There's a bunch of logistics and stuff to work out to make sure we can get it to the right place. And once this leaves, we'll be starting a second build for Joe Prussia, who's going to mimic, whatever I don't know what the word is. He's also going to do an equal donation of £2,650, and he's obviously paying for all the bill of materials and stuff for this second build. So that's all in parts in the other room. It's about 95% ready. All the printed parts and stuff. Most of the BOM is ready to go. That will be my first test of the bill of materials links that you see in the attached Google Sheets file thing. And yeah, that will be number 2. And then hopefully at some point we'll see you lot starting to build them. And of course, I'm looking to work, well, I'm already talking with LDO about trying to get a full kit available for those that don't want to really do the self-sourcing route, as that can obviously be a little bit of a difficult process, even if all the links are provided. So I've provided like most of the links, mostly AliExpress stuff. So a lot of it's really quite easy to get. Some things, not so much. Some things you have to contact a seller on AliExpress to get them to do a specific length or something. So that's the kind of stuff that I want to sort of talk through. It might not be very structured, I'm afraid. It's going to be a little bit back and forwards. But if you have any questions as we go, just stick them in the chat and I'll do my best to answer them as soon as possible. So, so this should be basically what you see in terms of the bill of materials. It's kind of basic format-ish, I suppose. You've got your category, which is not an assembly. It just kind of helps you buy a bunch of stuff sort of together that's similar. The name of what you're looking for. The BOM quantity is literally how many you need. And then the UOM stands for unit of measure. So in the way I've done it, it's either pieces, as in a what do you call it? Discrete quantity. So things like bearings. Obviously, you're not going to be buying half a bearing. So that would be in pieces. And then the other one is in meters. So you can buy half a meter of tube or wire and stuff like that. So those are the two things. That's what UOM means. The shop is just a general idea of where you can get it. Most of them are AliExpress. A lot of them, though, I've put for like local reseller, like fasteners and just stuff you can easily get on Amazon. SD card, I think, is one right at the top there. I've not bothered with links for those because I'm sure if you just Google the name 32 gigabyte SD card, micro SD card, you'll find what you need. That's just obviously for the Raspberry Pi. I've left a space for alternative links, although I've not really sourced any of those myself. A couple of them I've put like an Amazon link as the alternative, or where you can get it on like a mainstream shop or on AliExpress as like a clone. I've left duplicates there as well. In addition to that, so this is obviously going to be the public one. You'll be able to see this all the time. And I've also left a link here so you can go to the Vector 3D website and sign up for... You just have to put your email in here and click notify me, and that will allow you to basically get a notification, hopefully, fingers crossed, if I do it properly, when these become available for pre-order. This is not the price. This is just a price that I've put in because I have to have a price in order for the listing to be public, and I wanted it to be something that would make people question it. This is not the actual price. It's just a placeholder on the item. So I don't know exactly what the price is going to be yet of a kit. It's obviously a little bit down to LDO and how they source the kit and what parts they finalize with and all this kind of stuff. And then you obviously got margins and shipping and VAT and import taxes and all of that stuff all over the world. So it's going to vary, I'm sure, in places. But I think it may end up cheaper to get a kit rather than self-source. But I'm not really sure at the moment. It's all very much work in progress on that front. But the link is there if that's something else that you want to do instead. Buying a bunch of parts from a list can be a bit of a daunting process. So yes, that is the link down below. The second thing, oh no, I've opened the same thing twice. Hang on a second. Send you back here while I go and switch screen. So the second thing I have here. Oh, what's the hell's happened there? Everything's just suddenly stopped working. Well, it worked on my computer literally 2 seconds ago. That's annoying, isn't it? Because it's changed the column number. This is why I don't really like Google Sheets as much as Excel. It's missing a bunch of function stuff that would be helpful. Anyway, this is a list that I can go through, and I've got some statistics as well that we can talk about in terms of what things are expected to cost, where you can get them, stuff like that, what assembly. Oh, look, all of this stuff's broken. Literally 2 seconds ago. I think it's because I moved a column in here. Maybe I should just fix that now. So this should be the item cost, but we have to find this column here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That makes sense. That's why it's gone wrong, because this was previously 14. And unlike Excel, you can't just double click to drop down. It just doesn't do it. So you have to drag it down like this, which is just seems crazy, but there we go. That's what it is. Hopefully that's going to be accurate. It looks like it's changed, but it should be okay. So we've got a kind of sorting by assembly cost and that sort of stuff. Where should we start? Does anyone have any questions they want to start, or shall I just babble on until somebody comes up with a question? Talk about BOM, what are we blowing up? So, I mean, it sounds like you're probably joking, but just in case anybody doesn't know, the term BOM stands for Bill of Materials, which is why it's in all caps. It's an abbreviation. A bill of materials is just a list of stuff that you need to make another thing. What inspired the build? Well, I wanted to do a sponsored build for the Sanjay Mortimer Foundation for Smurf, because it was auctioned off for charity, you see, which I explained at the start. And I wanted to, like, so the Sanjay Mortimer Rap Festival is obviously to do with the first bit, Sanjay Mortimer and that foundation, and then also being a Rep Rap festival. Rep Rap being the start of open source, freely sharing everything. Well, what started Rep Rap? This, the Darwin. So I was like, well, how can we make that maybe, because that's a significant part of Rep Rap, and we'll bring it into something that would be modern and desirable and fun for an auction. So yeah, it was just like an idea of, well, what is the most Rep Rap thing? This. And that was kind of the idea. If you were to do this again, would you change anything? Probably not, really. I did kind of have the pick of things that I wanted for this build. That's not to say there's not improvements that we can do down the line, but that's kind of with hindsight of the situation. Put in the same situation again, I would do exactly the same thing. I'm really happy with how it went, how it turned out, how it looks. The whole lot pretty much went really well. You shouldn't rage in here, really, but I've just remembered that I've got these things, and it's reminded me that the original build was sponsored. So while this stream is not sponsored, this build was, so I thought I'd give some thanks. I had these on show at Smurf Appreciament, so they obviously supplied all the filament, E3D, the Revo, and the Revo Voron, and this lovely set of nozzles around the front. Big Tree Tech, they provided all the electronics and some extra funding to help me build and have the time to work on it. So thank you very much to them. LDO, they provided lots of the hardware and parts and the bed, so they provided a lot of things to help the build. And of course, I'm continuing work with them to produce the kit, hopefully. And Rat Rig, of course, because they provided lots of the Z-axis assembly parts. A lot of the design here that's kind of developed on top of the original Darwin comes from other printers. So the Z-axis kind of general design, the Oldham coupler, the kind of thrust bearing in the above the motor, and all this kind of, the whole layout is based on the VCore 3. So that's where that comes from. This whole hot end stealth burner kind of assembly is literally the Voron stealth burner, just kind of converted into a block. So that's obviously based on Voron. And then a lot of it's just other basic kinematic design stuff. The whole bed is basically a Voron bed. So I did try to source parts when I was doing it that are also easily available, because if I made a bed in a custom size, it would increase its cost if we were to do something afterwards. It was not necessarily in my mind quite like that at the start, but I knew that having a deadline for a build, I didn't want to make things too complicated. The more complicated I make them, the more chance there is of something going wrong and me not being able to finish on time or not being able to source the right parts or something like that. So I went standard parts as much as I could to try and keep it sourceable. For those that don't know, maybe I should share it in the... So it's fully open source, obviously being based on open source projects, the Rat Rig, the Voron, and Darwin. So the whole thing is available on printables. You can get the whole lot. I've got all the STL files as well as the full Fusion 360 CAD, so you can really go all in. I've hopefully added that to the description. I presume it will update okay. You might have to refresh the page, but you should now see the printables link, or just search Darwin Evo on printables and you'll find it, I'm sure. So we can go through these and I'll just kind of comment on them maybe as we go if there's anything important. So I've tried to order this. I mean, you're not going to see this because this is the engineering bomb. But anyway, we'll order it kind of in order of assembly. A lot of this is fairly trivial. Steel hardened rods, some printed corners, threaded inserts. There are lots of threaded inserts in this build. There's like a couple of hundred. Of course, I'm going to recommend a VLMP as well if you want to build this printer, just because you've got a lot of inserts to do. But you don't have to. That's just me promoting my stuff that I designed. Z cross assembly. Oh, that reminds me. Yes. So in addition to the kind of original design, because we've got a mains powered bed, I wanted to try and add a little bit more earthing to the printer. So we've got these kind of earth straps, and they connect a lot of the lower half. So kind of here downwards is all earthed, all the metal rods and stuff. So there's just these little straps that join them all together. So those are all included in the BOM as these earth straps here. And the earth points, the P-clips, the joiners, inserts. So there's some of the inserts are designed for the CNC kitchen ones because those are what I had. There's a few M5 and I think a few M4, but that's mainly for this nozzle rack. I think that's the only place the M4s are. And if you're not going to install 8 Revo nozzles on the front, you probably don't need those. Most of the inserts are the standard Voron design. Of course, you can get CNC kitchen ones, and I sell those as well, but they don't have to be CNC kitchen ones, whereas the M5 ones are designed for that whole size specifically. So I would recommend you go for that intended size. Otherwise, you might need to modify the whole size in order to get the desired strength from it. The feet is something that I've added. The original just had, I believe, the metal rods kind of sticking out the base. in order for it to be kind of a little bit more finished as a printer, for me to be able to put it places like here and at Smurf without damaging anything. I've added feet, and these are just the kind of standard Voron feet that are on the 2.4. So again, nice and easy to source, shouldn't be a problem. The Z drives, so as I mentioned, the Z drive is all based on the Ratrig stuff. So you could go to Ratrig's website and buy a bunch of them stuff from there. But a lot of the parts that they use are, again, just kind of standard off-the-shelf parts. So you can probably save yourself a bit of money and buy them from just wherever. The Ratrig of the LDO Motors that Ratrig have on their VCore 3, I've put the whole model number in there, so hopefully you don't get those mixed up. Thrust bearings, screws. The Oldham coupler. So the Oldham coupler was one of the difficult things that I've had in this kind of finalizing the BOM. The Ratrig ones are pretty expensive. And in terms of like absolute cost, you can see 4 of them there is about £60, which is a lot. So I've got, when I do the Joe Prusa build in a couple of weeks probably, I've got some alternatives which are like cheap versions. I'm going to be trying them out to see if they're going to be good enough, because I think £60 is a tall order for 4 couplers. They are good, the Ratrig ones. They slide and slip really nicely. But in this specific use case, they may not be entirely necessary. I don't know. It's like the difference between £60 versus like 8. So considering it's like basically an order of magnitude difference in cost, I think some alternatives would be worth looking into. Before I go any further, I'm just going to turn off the printed parts because they can be done separately. The bed assembly. So the bed makes up one of the most expensive parts of the build. Excuse me, I feel like I'm just about to burp. Yeah, the bed is basically the... we can check based on the actual project summary costs. The bed assembly, according to this, is second most expensive. But it's also quite a simple assembly, so you'd think it'd be less expensive. I don't think the LDO bed assembly is available standalone anywhere. There are a few places that sell their own like top surfaces, but the actual metal plate itself and the silicon pads are not that widely available as like a combined or low-cost unit. So including the cost of the spring steel top, the magnet that holds it to the metal, the actual main metal core, the kind of cast aluminium plate, plus the silicon pad with a thermistor and thermal fuse, the cost like really shoots up. So for not very many parts, it unfortunately costs quite a lot. I shared a tweet a few weeks ago about considering alternative ways to make beds that would be cheaper. And obviously my disassembly of the A1 kind of prompted that a little bit as well. Because the way we're doing it currently is... Excuse me, I don't know why I'm yawning. It's probably the lights. Maybe it's the lights. Yeah, the way we kind of make beds at the moment is working really well. Like the addition of spring steel sheets a little while ago, quite a few years ago now, that made a huge difference. The flat aluminium plates has been great in terms of flatness, but all of this stuff has come at quite a big cost. And the other thing that makes me a little bit not nervous, but it feels unoptimized. Well, because it is. Because the way they have the hot end relative to the gantry on this specific design, you only get about 230 mil in Y. So of a 300 something bed, you're losing 70 millimeters of that travel, which is quite annoying. And maybe either somebody else will design an upgrade, or I'll do an upgrade soonish at some point, a bit down the line, as an alternative tool head design where we can make full use, or at least like a 95% usage of that bed surface. as opposed to the kind of gap solution we have at the moment. The nylon filament, this might seem like a weird thing to have in there. This is something I kind of picked up from building a Prusa Mark III many years ago. Obviously, my Mark III still has that nylon filament in, and it seems to have been a really good solution, well, a low-cost and accessible solution at least, for kind of controlling how wires are moving and that they don't droop over time or have kinks or strain or anything. So that's basically to put in a kind of wire wrap with the wires from the bed down to the mains power, just to keep it in like a constant circle kind of bend. The reason I've used nylon there and in the umbilical for the tool head I've used steel is that obviously the difference is between like this being 24 volts and that being 240. If you touch something that was 24 volts, you probably wouldn't notice. Whereas you touch something that's 240, you're going to flip and notice. So I was like, let's keep that all plastic so we don't have any risk of, well, A, the metal damaging the wires, and B, conductivity through that strain relief. I've tried to include all the wires, connectors, terminals, and literally everything in this bill of materials. So if you're like me and you've built printers before, especially like all the mains bits and wiring up control boards and stuff like that, the likeness is you'll have a lot of these connectors already, and some of them actually come like with some of the hot end and whatever anyway. So you probably won't necessarily need to buy all of them. It's difficult for me to judge in terms of a kit what should be provided and what shouldn't, so I just put everything in. The reason being, when you're making a kit, you can put in a specific quantity rather than an entire bag. So that's one of the areas where the kit can be much more cost effective than self-sourcing, and that's something we can take a look at in a minute as well. Actually, I have some stats on it. I'm going to lose my voice if I keep talking for the whole time. Never mind. The Y Gantry. So the Y Gantry is quite a bit different to the original design. The original, in fact, the motors almost entirely are very different because they were NEMA 23 in the original design, whereas I've switched over to NEMA 17, mainly because our motor technology and specifications, understanding, and all this kind of stuff has improved, I think, quite a bit. And these NEMA 17s are very easily, widely available, as they're basically from Rat Rigs and Vorons, so they're just standard motors that you can already get. The original design had a motor on one side with a very long 8mm shaft that came over to this side, so you had one side that was driven and one side that was kind of connected to it, and that gave you the belt movement of two sides. I changed that to give a little bit more visibility and access at the front and added a second motor. So we've got motors on the left and right at the front. So you've got one motor here and one motor here. This motor you see back here is for the X axis. Again, a single motor, slightly different specification. The pulleys in the original design were all 3D printed, I believe. And I think part of the reason for that is that pulleys of pretty much any quality were very expensive, and since the whole point of the build was to make it accessible through obviously printing a majority of its parts or having low-cost off-the-shelf parts, pulleys were not a low-cost off-the-shelf hardware store kind of part. Whereas nowadays, well, you probably couldn't get them in your local hardware store unless that store happens to sell 3D printing spares. They are really low cost. You can buy a bunch of them for very little money. So I figured it makes sense to go that route rather than trying to print them, because inevitably, if you're trying to have higher performance, a printed pulley could let you down a little bit. I've added separate grub screws for the pulleys. The ones that I ended up buying that are linked on the bill of materials actually came with the grub screws, but ones that I bought off Amazon didn't. So depending on where you buy them, you may or may not need those. hopefully whatever you buy will come with them. One thing about hardened steel rods, there are some that are very specific lengths, like this one here. Oh, can I zoom in? This one here being 472 millimeters. I can't remember exactly which position that goes in. That'll be the Y gantry, so probably the Y idler. Yeah, probably can be longer. Like, they stick out the ends anyway. It's not like a perfectly fitted length. It just happens to be the length from the very original design. You could potentially even go for 500 and it'll just stick out the sides a little bit more. Wouldn't be a big problem. But 472 is the kind of intended original design. That's going to be one of the parts where you may have to message the seller if you're going through, for example, AliExpress. Sometimes they list on their page, these are the lengths that you have, or you can contact us for a custom size and they can cut it to any size. So in this case, you might have to ask for the specific size. I'm assuming they'll charge you at a similar rate, or they'll charge you for like a 500 and then cut it down to 472. Hopefully. I'm not exactly sure how that's going to work out at the moment, but hopefully it will be fine. In terms of linear bearings, I'm losing my voice. Oh dear. So we've got two types of linear bearings. For the Z, we've used LUU rather, the kind of double length ones. Whereas the Gantry head has the graphite brass ones, which is the kind that you can find in the Crowty and Bamboo, the K1 and Bamboo X series, and P1 series, I think. And also the Y Gantry ones, you can actually do either. So, I mean, you could do either anywhere probably, but I chose to use the Element LUUs in that Gantry side. You could probably put the graphite ones anyway. You just need to make sure you buy them in the right size configuration. The drag chains, again, I've spec'd the same as the Voron ones. There is only one drag chain, and it's for the X. Because there's a motor that moves on the Gantry, I've kept a drag chain for that. There's literally one cable in it, and that is the motor cable. So maybe not the most cost-effective use of a drag chain. And if you maybe want this as a museum piece rather than to print on it, you could probably do without it. I don't know, up to you. The screws and fasteners in the bill of materials, because there's no kits like specifically just for fasteners or anything like that, you will have to kind of hopefully be able to find a local supplier which sells all the various different lengths of M3 screws. I've tried to standardize them as much as possible, but there's still quite a few different lengths. Unfortunately, that's just sort of the way it is. Inductive probes. So as I mentioned earlier, the hot end extruder design is basically Stealth Burner and Clockwork 2. Internally, that's what it is. I've just added material to the outside to make it a bit more blocky. Oh. However, because it's mounted to a different setup, these twin rails instead of the normal kind of 2020 extrusion and a linear rail, you can't just fit any single probe in there because there's basically a rod that goes right through the middle of where that would normally go. So I fitted a Pinder probe, and that has space, but the larger fatter like Omron probes, or the red ones, I don't know what spec they are, but those other kind of squarish probes are not going to fit. Now, I would say it might be possible if you do some modification that you might be able to get it to fit, but I think by the original design that I have here, there's not enough space. So just be aware of that. If you're hoping to use that design, it may not work, which is why I've linked the Pinder probe or inductive type 8mm probes instead. Moving on to other parts of the tool head. So I've designed this obviously for E3D's Revo Voron, because I went hot end for stealth burn and all this kind of stuff. Technically, you could put any hot end in there that you wanted. You might need to, if you want your aesthetics to be consistent, you might need to modify the stealth burner mounting from like the original stealth burner mounting for that hot end into a QB design that matches this, which is actually not that easy, but can be done without too much trouble. I think the original ones will actually clip in. They're just aesthetically not look quite right. So you can give that a go if you want to try a different hot end. I know E3D's Revo is not necessarily the cheapest out there. So if you want to try something else, you do you, but this is the one I'm recommending, as this is the one that was initially designed for. Same sort of thing with the BMG kit. So again, Clockwork 2 uses this little Bondtech extruder gear. You can get clones. They're a lot cheaper. I've linked both, I think, in the BOM. The main ones at 3D Jake and the clone ones from AliExpress. I would expect the Bondtech ones are more reliable and a little bit better machined, but I mean, you can get pretty well machined stuff from China, like they're manufacturing everything inevitably. So it's not that you can't get it there, it just has to be specificated. It just has to be made to the right specifications. So if you've got a place that you trust, or you've bought them before and you know that they're good enough, go for the cheaper ones if you want to, but I've again spec'd the Bondtech ones. So when we look at the pricing and stuff of the final kit, this is all based on like the proper stuff, you know, the genuine stuff, the stuff that I've listed, the stuff this is made with. So, you know, your mileage may vary both up and down depending on where you are and what parts of the kit you choose to go with. Similar story for the can board. So I've gone with the Big Tree Tech one. In fact, let's just talk all control board stuff here. The control board, the can to USB, or USB to can, whatever, and the tool head board, and the screen. Like, none of these are really required to be exactly what they are. If you want to use a control board from a different place, then you can do that. Obviously, the configuration stuff I have and I'm sharing with the open source files and everything, that's all going to be for this exact specification. But if you're comfortable doing some modifying of that specification and the, you know, the printer.cfg file or whatever, setting up your own CAN bus from a different manufacturer, all these kinds of things, if you want to do that, you absolutely go ahead. Pretty much anything should fit because we've got a DIN rail mounting at the back. The screen spacing is really open, like it's a very open printer, so you're not very constricted by space. You should be able to be pretty flexible in what you want to do. The Nomi, another great example. It's one of those things that I kind of wanted just because it looks really nice. It's a nice little demo thing for a show. It's very cool. It's a bit different. People have not really seen it before. But at the end of the day, it doesn't really add in terms of performance. It's kind of useful. It displays some data. It looks kind of cute. It's literally just fun. But again, doesn't really add performance. So if you wanted to save yourself 20 quid and go with a slightly different design, then you could probably manage that. Is there an enclosed version? No. That's the simple answer. I mean, yeah. No, currently, no. If there is, it will be a long way off. I've not made any attempts to change or improve the design at all at this moment. My initial goal really was to get first kits out. So you're building this exact specification from original kits, and then we can build on it from there with mods, improvements, and make additional kits for any of those modifications which we add to it. That was the kind of plan from my side. Obviously, the problem is if I keep changing things, if I'm changing this design every 2 weeks and go, oh, I'm going to put this in and take that out and put this in and take that out, it's impossible for LDO to make a kit because you need stability in the design. So we're keeping the design the same. for now. If you want to make mods, you go ahead. Like, it's fully open source. You can download all the Fusion files, tinker as much as you like. That's kind of the point. But in terms of the official kit, it will be the official design. Are you going to give out serial numbers? That's a good question. So I had considered it to the point where I made this one serial number 1. Because this is the one that we made for the show. I say we. I mean, I made it and I had sponsors provide parts. So I suppose, yes, serial numbers are a thing. I want to avoid it being some kind of elitist thing. Like, I don't know how we can manage it. But I think serial numbers could be fun, and I'd like to be able to give people that kind of little reward for finishing the build. I just don't know what mechanism we do it by. I'd probably need to talk to the Voron team and how they do it for any recommendations on how to do it without it getting out of control and taking all of your time. So at the moment, this is number 1 and Prucha's will be number 2. But I've not made any database whatsoever. So it's all just it's all just here at the moment. Did Adrian Bowyer get to see it? Yes, he did. He stopped by twice actually, and I got to talk to him. And Claire from E3D took a photo of us together with the machine, so that was pretty cool. Moving on down the list. Stealth burner RGBs. So in here I've put as a full harness. I think wiring up the harness yourself is kind of just an annoying little task. And it's quite easy. There's quite a few harnesses available on AliExpress. It's just an RGB LED, RGBW LED actually, with some little wires and a connector on the end. I think it's much easier to get it done that way. That way you know the lengths and stuff are appropriate and it'll fit. So here I've put the Revo rack stuff. So the Revo rack is the what I'm affectionately calling this thing at the front with the nozzles. This is 2 Revo racks. If you're not doing Revo, obviously you're not going to find much benefit from these. And equally, if you don't just have 8 Revo nozzles laying around, which you also probably don't because they're not particularly cheap, then you may not want to do that at all. You can save yourself a little bit of money on some heatset inserts and a couple of printed parts. Electronics mounting, as I mentioned earlier, so all the mounting stuff, all the electronics is mounted to DIN rails. So the reason for doing that was flexibility, because as I was doing the development, I obviously wanted to add and change things and work out what would fit and what doesn't. If you can't get it in 330mm, if you can only get it in 400, I'm pretty sure that fits as well. Yes, that will fit. So if you don't want to cut it down, you don't have to. You'll have a bit more wiggle room, a little bit more space, and it'll still fit just fine. So I just went with 330 as that was one of the standard Voron sizes. So if you go to somewhere that sells Voron parts, you'll probably find 330. If not, 400 is fine. 300 though will probably be a bit short because 330 only just fits. Power supply. So I believe in some places in the world, oh, excuse me, in some locations, the Meanwhile LRS power supplies are adequate, but they don't have power factor correction, which my understanding is at 220, 230, 240 volts, in that range, can be problematic. So the LRS series are not approved for use in the EU or the UK. So I've put in the RSP 320/24. If you're in the UK, I sell these. If you're not, I mean, it's meanwhile, I'm sure you can find a seller. These terminal blocks, so these DIN blocks are the same ones that LDO use in their kits. So they're pretty easy to assemble. They're just kind of a bunch of colored bits which you block together, and that helps a lot when it comes to the mains wiring. More control board stuff. The TMC 2209 drivers are a little bit annoying in terms of purchasing because you need 7. You kind of have to buy either 2 kits of 4, a 5 and 2, or a 6 and a 1. The pricing of them seems to fluctuate, so it's not necessarily consistent which of those options is the cheapest. You can't buy 7 in a single kit, so you always have to pretty much 6 and a 1 allows you to buy 7. I think that's the one option that allows you to buy 7, but 2 is only a fraction more expensive than 1. So you end up buying like 6 of them for £12 and then an extra 1 for £5 or something. You just double check when you're buying which is actually the cheapest way to get 7, as it does change a little bit. The Bigtree Tech U2C, this is the thing that converts USB to CAN bus. Apparently, you can use the CAN bus on the control board, although I always use one of these U2C adapter things, and I found them very consistent and reliable. So that's why I've used it, and I'd probably recommend you do the same. I think the one that comes on the control board is like a software solution as opposed to like a hardware solution. So in theory, I think they both work, but I've found this one really good and it always seems to work. So, and I know a lot of people have had problems with CAN, and maybe that is one of the reasons why. I don't know. Raspberry Pi 4B, other options will be fine. 32 gig micro SD card, a screen. So the HDMI 7 screen has actually seems to have gone up a version. So the design will need to change a bit from the STLs that are available at the moment. I will need to do those modifications for the build that I do for Prusa. I don't know where I'm going to do that. Just be aware of that. Hopefully no one's going to be racing ahead in terms of builds compared to me. So hopefully that's not going to be an issue for anyone. But if you are printing out, that could be something worth considering. Just don't print the screen yet until I've done the update. The illumination on the front. Again, this thing is very optional. I did it for the show, really. So, I mean, it's kind of a showpiece. It's an LED. It's a name. It kind of tells you what it is. If you're just doing it at home, it looks cool. I'd encourage you to do it, but don't let it stop your build. If you're missing some of these parts, you can do everything without it. That's pretty much it. And then it just comes down to filament at the end. The accent main colors is a bit of a weird one because for this printer, the way I did it was like basically everything main and then a couple of green accents. So it's like just over 2 and a bit kilos. I think it's just over, I weighed them all. So just over 2 kilos of main color, but it's only like a few grams of the accent color. Literally 10 grams, 5 grams, 5 grams, or what was it, 100 grams, 50 grams, 50 grams. I think even this was too much because I did it in the summary. I added it all up. 2012 grams of main color, 15 grams of accent color, 10 grams of black, and 4 grams of clear. So hopefully you can get samples for those other parts. Again, this is the kind of thing that reflects poorly in the price because I priced it as if you need to buy 4 different colors. So you have to buy a clear, a black, an accent, and a main color, or 2-3 kilos of main color. So that can be quite expensive, but if you already have a color that you can use as an accent, you can do that. Black you could use as your accent color, and that would save you as there. And then clear, you could buy that as like, that's just, I think the insert, I think is this clear, and then this clear down here. So you might be able to find cheaper ways of doing it without having to get a separate kilo of material just for a few grams of clear. I might not have added that up right, because I feel like that naming is more than, so I basically, when I printed out all the parts, there should be a clear one here. Diffuser clear. Oh, that is the 4 grams, 3.4 basically. Yeah, very little clear filament. So yeah, that's basically the full engineering BOM, excluding printed parts. There's not much to talk about with printed parts. Unfortunately, I've not orientated them yet, I don't think. So all the ones that are there, you'll have to work out the best orientation, but it should be fairly simple. It's not too difficult. What else is worth explaining? So this is a bit of a breakdown in terms of the number of parts from each, because obviously the point of RepRap was to have a significant proportion of its own parts be 3D printed and the remaining portion be off the shelf, easy to access things. So luckily for us, the electronics are especially easy to access now, so we can kind of have an electrical purchasing stuff as well. Even though it's not like down the road hardware shop, in my mind, buying a bunch of electronics off AliExpress is just as easy as walking down the street to the shops nowadays. So in terms of ease, it's still similar, and the pricing I think is still pretty reasonable. It's not like industrial level pricing, so I'd call it accessible enough to be acceptable. That's just my opinion. So we've got 40% printed parts just by quantity, by number, and then nearly 30% electrical, 17% hardware, and 14% fasteners. And then there's one bespoke part. Of course, that bespoke part is the wooden part. So the price in the BOM I've put as the UK price for a piece of plywood cut to the external dimensions. So it's 398 by 398 millimeters, and that costs in the UK about £35 to have delivered, which is quite a lot for a small piece of plywood, but it is what it is. And then you would need some tools to cut it out. You don't have to cut out quite like perfect geometry like I have. There's a couple of bits you could just not cut out, but I would definitely recommend a nice big hole in the middle, because you don't want that bed heat being absorbed into the wood. You'll end up with kind of charring and potential fire hazard. So keep it nice and open, allows for lots of airflow through there, and then you'll be fine, I hope. I also did a bit of a cost summary to see where we're spending money, what regions of the printer, well, which of these categories, which have that number of parts, cost how much. So, I mean, that's just the one part. So you can see the £35 spent on the bed, 700 odd pounds on electrical stuff, 600 odd pounds on hardware, 70 pounds on fasteners, and 168 pounds on filament. Again, that filament figure is really inflated because we're buying a spool of clear, a spool of black, a spool of accent, and 3 spools of main color. You can definitely do it cheaper on the assumption that many people building this already have multiple colors, multiple filaments, maybe an entire rack of filaments to choose from, and don't need to buy anything. So this is almost, I'm hesitant to say it's like a worst case pricing, because I'm sure in some regions, like for some reasons, pricing of stuff will just be higher and you won't be able to do it for this cost. But this is like an all-in, I have to buy absolutely everything apart from tools. That's about what it costs. About £1,600, which is a lot, I grant that, but that is sort of worst case. Like, this is a very expensive bed, this is very expensive on filament, it's very inefficient in terms of the parts you're buying. We can go have a look at that now. So I think I did in pricing. So I spent a lot of time So obviously I looked up all of these separate parts. We've got the BOM quantity. So this is the kind of summarized quantity. Oh, the unit of measure I explained earlier. The pack quantity. So based on the shop we're buying it from, this is how many get in a pack. And therefore we can do the maths to work out how many packs are required. We find the pack cost by looking up on the shop what that thing costs. We work out what the shipping cost is. Most cases it's zero, luckily, especially if you buy all the things together. If you end up buying them very sporadically, if you don't meet like certain quantity or value requirements, the shipping will end up being charged. But in a lot of cases you can get it for free. And then the cost, the total cost, and the cost per piece. And that's how we've done the engineering BOM cost per line item. And then at the end, we have spare percentage, and spare value. So the spare units is if you need, for example, this is a good example here, this 98 one. I need 2 of something, but it comes in packs of 100. So I have to buy 100. I then have 98 spares. So that's a 98% spare ratio. And the spare value is £2.62. So that's money that we've spent in order to get the parts, but will not be using to build the printer. So we kind of have that left over. So the spare value is the value of the things that we bought, but didn't use to build the printer. And you can see as we look down here, there's lots of parts that have this spare value. So the things that you have to buy because they come in like minimum quantities. And you end up buying more than you need because that's just the way it goes. This is also a fairly optimistic view on the fasteners side, because I know in the UK there's very accessible fasteners where you can buy literally single pieces, whereas in other locations you might have to buy bags of 50 or bags of 100 in order to get 5 of them. Whereas I know here in the UK there's suppliers, Orbital Fasteners, I mentioned them, is not sponsored, but I use them a lot. You can literally go, you look up the screws and you get whatever precise quantity of any one that you need. They're absolutely fantastic. If you're in the UK, I would recommend going there. It's just an easy way to do it. You risk mistakes from translating off the BOM and everything, but it's pretty accessible. For people elsewhere, I try and avoid using eBay and places like that because those sellers sell at inflated prices, because they're basically buying 1,000 of these screws that they get for a pence and then sell them for like a bag of 10 for £10 or something outrageous. It's not very fair. So do yourself a favor and try and find a supplier local to you that sells fasteners. They must be all over the place because there's engineering firms all over the world building things with these screws. So hopefully you can identify places close to you that do that. So looking at that value, this is a summary of what we spend and where it goes. So you can see that £1,600, that's the total that you need to spend in order to get all the things you need. But the value of parts that you don't actually put on the printer is £220. Again, that's viewing the fasteners in the optimistic way of being able to just buy one at a time. So yeah, it's about £1,400 of printer and then a couple of £100 of general electronics and hardware and stuff that you can use on other projects. That's one of the advantages we can have with a kit, is we don't need to, we can buy bags of 100, we can buy 10 bags of 100 and then supply 1,000 kits using those bags. So hopefully that's where we can bring the price down for kits for you all. What's the build volume of the Darwin? That's a really good question and I've forgotten off the top of my head. You get pretty much all of the X. So you get like, I think it's like 280 or 290 on X. It's about 230 on Y. And I think it's about 180 or 200-ish on Z. I might be able to check. I can't remember. Yeah, we don't have network connection on here at the moment. there. Yeah, I can't remember exactly. I think I put it on the shop page, actually. I'll go have Luke. No, I didn't put it there either. What a nitwit. Hopefully that answers your question enough. It's not the full Voron 300 build volume. That's not what you get. It's reduced a bit from that. So yes, that's the spending. That you don't really need to worry about. This is part of an evaluation of how we determine what to put in a kit. So the plan is to do a full kit of absolutely everything, but it's difficult. Some things easy to get, some things not easy to get. Sometimes adaptations and whatever are required. Sometimes it might be easier to have flexibility. So we buy all the stuff that's difficult to get and allow you to deal with the easy things. So things that are already easily available from thousands of resellers, you might as well just do that yourself. Whereas things that are difficult to get, things that are custom sizes or specific lengths or specific quantities, maybe we'll put that stuff in the kit. So I've just kind of separated out stuff that's easy to get, fasteners, and stuff that's hard to get. Hard to get. Like, it's really not that hard. I don't think anything in this build is really hard to get. Everything really is pretty accessible. But some things take a little bit more effort than others, or are just less efficient to buy on your own. Probably not the point of the printer, but what sort of speeds and accelerators do you recommend on using for this printer? So the profile that I have, I think the travel was something like 8K. I can have a look actually now. I realize I have Orca Slicer and it syncs my profile, so hopefully I should be able to get that. Oh, it wants to download and upgrade. No, don't do this. No, go away. We'll do that later. Oh. So, what is this? Needs an update. I don't have all my profiles here. Oh well. So I think this is the generic profile that I made. This might not be the best one. Yeah, I think this is slowed down a bit from what I had. Oh no, travel 8K, normal printing 3.5K, normal 5K. And then I mean, in terms of top speed, you can hit 300 or whatever, that's fine. Obviously slowed down for kind of quality. And then the accelerations are not too high just because of the cantilever effect we have on this big tool head on these rods. It's one of the things we'll look into in the future as an upgrade or improvement, because the printer is definitely capable of more. The problem is just the stiffness, rigidity of the gantry. I want to improve it. As I said, it was not designed necessarily to be a kit originally, so it's fine. It works. It works pretty well in terms of print quality. It does benchies. It does good benchy. But what it doesn't do is like Bamboo Lab insane performance things. Yet. I think we can get there. What were we going to look at? Oh, that's the public one. Here we go. So this is a summary of the costs of each assembly in order. I don't know how important that's going to be for anyone, but I thought I'd take a look just because I thought it was interesting. I like doing the little mathsy things, these little pivot tables, to understand where the money goes. Because when you pull up your cost, you're like, oh shit, £1,600. Where am I spending all of that money? Well, a lot of it, as you can see, is the tool head, where you've got the Bondtech gears, which are expensive, the Voron tool head, the Revo, oh, goodness me, E3D Revo Voron, 60-watt heater and premium nozzle. I mean, premium like a high flow 0.4 nozzle or something. You have a Pinder probe, which is pretty expensive. You have the tool board, which is reasonably expensive. You've got the Nomi, you've got the extruder motor. There's quite a lot of expensive hardware in that tool head, so a lot of the cost goes there. And you've got the bed assembly, which I mentioned earlier. It's just expensive. These tool plate beds and spring steel whatsits are all expensive little things. They soon add up. And the Z drives, I think it's a combination of just being 4 of everything. Lead screw, motor, bearings. It's just quite a lot of stuff. That's more expensive than I was expecting. Let's go have a quick look. So we can go here. We can clear this, sort it by just the Z drive, if I can find it. Filter. Well, that's clearly wrong. Some of my maths is not working out in the spreadsheet at the moment, so the costs end up a little bit wonky. But 4 motors is definitely not £75, so I don't know quite what's going on there. Lead screws, everything else, yeah, those are really expensive. This doesn't look quite right. I've not shared the costs publicly. They've been kept private at the moment just because I know that they're not perfect. I don't want people relying on them. So hence the public one is just the information, the data, and a link. If you want to do your own cost analysis, you're more than welcome to. Saw this little beastie at Smurf, and dang, it's beautiful. Thank you very much. I think so too. It's amazing how everything just adds up. No number is massive, just a lot of... Yeah, it's just a lot of parts. That's literally all it is. Which is why every single thing that you do, if you're trying to make a cost-optimized machine, you have to consider it at every single point. You can't think, oh, well, this is only this amount. This is only £5. This is only £10. This is only £5. Suddenly you build a printer out of stuff that's only £5, and suddenly it costs £2,000. So, yeah, I think if you were trying to save yourself some money, you could probably go for some cheaper electronics. You could probably cost down your tool head quite a bit. You could probably find a cheaper bed that would also work similarly. You might need some modifications, but if you want a similar printer at a cheaper price, those are the areas. That's kind of what this thing tells you. By looking at this, you're like, where are the areas where I might be able to save £100? I mean, for example, you're not going to save £100 on the front name Illumination because it literally costs £9. But this costs 237. So could we save a bunch of money there? Maybe we could. What it doesn't tell you is like the percentage of potential savings. So saving like, you might be able to save 60% of this cost, but only 2% of this cost. So, you know, swings and roundabouts, yibbity yabbity you. Basically, if you want to look at saving some money, these top assemblies are the ones you might be able to do it. And there might just be some maths what I got wrong somewhere. We can go and inspect this one. Yes, £75 can't be right for this motor, because that makes one of them like nearly £20. Which might be right, but I don't think it is. Pricing list. Oh, according to this, a pack costs £18.95. Oh, it might just be that they are £18.95 each per motor. Yep. They're just expensive motors. So, there you go. It's not wrong. £75 for 4 of them. You do have to be a bit careful with steppers with lead screws, because if they're not loaded correctly, then they might not work super well. I'm not sure. Depends what the internal design is like. You'd hope it'd be adequate. Just wondering if the assembly will all work if you have integrated ones. Yes, that should be fine. You could potentially save some money. Again, you can kind of do what you like. You can test it. Because you've got the Fusion file, you can maybe draw a simple model of the one that's an alternative, jam it in, and see if it works. The thing that you got to be most careful of, and again, maybe do a modification which could help, is that the lead screw length has to be very specific because the block sits in a specific place and the lead screw can't extend into the block. You could potentially save yourself by cutting holes in those blocks that are larger than the lead screw, so the lead screw can go up through it, but at the moment it doesn't. So the lead screw at the moment has to be 281 millimeters long, which is exactly the length which the rat rig ones are, which is why I went with them. Well, that's not why I went with them, but that was one way I could get them. So yeah, there are lots of areas. I mean, I say lots of areas. There are some things like that, like I mentioned with the tool head earlier and this thing now, where there are places where I'm happy that I've done it, it works and it's good. But to kind of cost optimize things for the future, there are maybe ways we can make maybe the assembly process a bit easier, the part selection a bit easier, the availability a little bit easier. But at the moment, I'm sticking with as it is because it is good and it does work. And those are the main two things. My throat is starting to die, so we may not be much longer, but I have been yapping on and on for over an hour. I think I already uploaded the Clipper config files and stuff. Oh, I just kicked the bottom of the camera. Yeah, I think I already uploaded the Clipper config to printables. If not, I will try to do that soonish. It's pretty easy to configure, really, because it's quite a simple printer. Quite a simple printer? I don't know. It depends on your experience with Clipper, I suppose. I've done quite a few Clipper printers, so for me, it wasn't too bad. It was pretty easy. But if you're not experienced, then it might be useful to have a pre-made configuration. Are there any questions? Hopefully you've had time to have a look at the bill of materials. Did anyone test if they can copy it? I'd be interested to know if you can. I'm hoping that if people want to, they can save a copy of this, the BOM sheet, and kind of add the columns or put it in Excel and do their cost management and part tracking or whatever that they want to do. If someone could just test that they can copy a version of it to their own local machine or own Google Cloud or whatever, that would be fantastic. Just so I know that it works. And then if there's no more questions after that, then we'll probably call it a day. Would assume it scales down well. Probably. We might look at doing smaller sizes at some point. Yeah, I mean, it should scale down fine. I mean, one thing that would be definitely kind of cool would be to have basically a script. It's kind of it's another thing that I wanted to do on another print I designed myself, is that your design is very adaptable in its size. In that if you put in the rod lengths that are available to you, and the geometry of the printer will change according to what you can get. So if your print bed size can only be this, well then it shrinks that, and these are the rod lengths you need for that size printer. That would be nice to do. Also a lot of work. Haven't done it. This one is not the Joe Prusa one. The Joe Prusa one we'll be doing as a full live stream build series. All the parts are in the other room. This is still the OG one that's going to be shipped off to LE in America soonish. The designer of the Dueling X has done a parameterized CAD in Fusion 360 for scaling. That's pretty cool. Is the Dueling X the self-printing printer that prints bigger as it prints or something? Not a Darwin question. Would the VLMP handle having a Dremel 225 flex shaft mounted to it instead of a soldering iron? This is something I've been thinking about for quite a long time. The answer is I don't know, because I've not done it. I've seen recently another design of an entire Dremel being attached to a small tool like this, and personally I think it looks dangerous. It's not... A flex shaft could be a slightly different option that could be more viable. Two tool heads on two carriages on a V0. Nice. So an IDEX V0 basically. A printer for ants version. Yeah, a V0 size bed, that would be kind of funny, wouldn't it? A lot of work also. Maybe one day. There's a lot of stuff on my plate at the moment, so we'll see how this one goes first, and if LDO want to make kits, and where that situation gets us to. I'd love to see other people start building them, although I just don't really have instruction manuals, do I? How much? I suppose it's going to be a really big barrier to entry. How do people feel about instructions? Oh, excuse me. I mean, obviously, I didn't really need instructions to build it myself, because I did the whole thing in CAD, so you already know where all the things go. The overall design of the printer is pretty simple, so I might be able to do some like simple instructions, at least simplified instructions, where it's just like start with this bit and do this and these pieces in like 8 steps or something. Of course, it doesn't take 20 minutes, it takes a few hours, but largely it's quite simple to do because all the corners are kind of copied. Yeah, you do have the whole CAD. So if you want, the way I structured the CAD as well is kind of in the assembly order. It's not exactly, but if you were to go through it in that order, you'd probably be able to work it out pretty easily. And the printer does end up kind of modular in a weird way. Just by way of the way that it's created, I suppose. How hard is it getting the rods all aligned and square? And what has been the hardest non-printed piece to source? So, how hard was getting the rods all aligned and square? Actually, not that difficult. I don't know that it's perfect. I've not actually printed a cauliflower on this printer, and I really should have done. That would be a really good idea. Or did I? Maybe I did. I can't remember what the results were. Anyway, it's kind of mostly square. And the thing that makes it quite easy is that I've used grub screws. Well, it's not a grub screw, but it's a heat set insert and a short screw. And as you screw the screw in, it grabs the rod, which makes it very easy to loosen and slide them. Whereas in the old design, you had to kind of, I believe, the smooth rods kind of pressed into the plastic, which is very difficult to adjust in like a fine amount. Whereas mine, you loosen and it's really free to move. So you can just kind of measure diagonals, move it a tiny little bit, screw it back in. It's very easy to adjust. So I didn't really have any major troubles with doing that. I thought it was going to be harder than it was. So I did that with like the main frame, and then these cross braces, you put them on loose, and then you just tighten the nuts from the two sides, and it just locks everything in place. Pretty good. What was the hardest non-printed piece to source? I mean, the part that I couldn't source was the wooden bed. I had to buy a piece of wood and cut it myself. I don't know if that counts. Nothing else was really hard to source. Like, I had LDO help with a lot of the rods for me. So the custom sizes, I was just like, can you send me these in these sizes? And they're like, yeah, sure, we're happy to help with the project. Da, 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 da. Here they are. So that made that part easier for me. I'm guessing the CAD is the instructions. Yeah, basically, yeah. No, I think I already mentioned they're already in order. Are you going to build Joe's on live stream? If so, video instructions. Yes, good point. That will be basically video instructions. That is all going to be live. The whole thing from start to finish will start when I have all the parts ready. The first thing we'll be looking through all the parts. I think it sounds kind of boring, doesn't it? But I think for people looking to build their printer, that might be useful. And then, yeah, we'll literally try and do it. The reason I want to wait for all the parts is because I want to do it in order. Sometimes it's tempting to start a build and just kind of, well, we can do this bit, we can do a bit of this bit, and then jump over here and do that, and then do this, and then do this out of, you kind of do everything out of order, and then it just happens to come together at the end once you've kind of done all your bits out of order. Whereas I want to do it in that kind of logical instructions way, so you could follow through it as video instructions if you wanted to. It probably won't be in like perfect zoomed in kind of thing, but hopefully it's enough. And we can help. So let's get in the way while you build it live. You got to do it in Prusa Orange. I think we're going to be doing it in just the same. It's going to look exactly the same as this one. I think so. I talked to Joe and he's like, the natural is good. So we're going natural. I have some ideas, some secret ideas in my head for alternative versions that I'll build later on. But initially it's just going to be this standard, because the thing that I think that's really nice about this, maybe even more so for people that have been around 3D printing for like 15 or 20 years, is that it has the kind of aesthetic that we saw from printers back then, but in a sort of tidier way. Whereas I think printing it all in orange would take a little bit of that away. Like, it makes it look like a more modern Mark II, Mark III era printer, Mark IV era printer. Whereas it's nice that it looks like we don't have any choices other than natural, which is like what we had, well, I believe was pretty much what was available early doors. Would you Evo-ize them? I don't know what you mean. Printing a wood effect filament. You could do. That'd be a bit interesting. The Mendel. I mean, it's been in my mind. Obviously, once I did this one for the first Smurf, the question immediately comes, well, what about next year? Either we do an updated version of this, or we pick another very old design and completely redo it for next year. I don't know. I might try and go for something small, because I know Sanjay's first printer, like the start of E3D, was the Huxley. So I might try and do that one, because that's a nice little cute, adorable printer. Be wary of accepting awards for this. What? I've got the feeling that with a printer block printer, but other people wants it's printing. I don't, what? Oh, the Darwin Awards. I see. I get it now. Yes. Bit slow today, me. Where did my water go? Oh, the wood effect filament. I got detoured. The downside is I think most wood effect is PLA. Most of the printer would probably be fine in PLA. PLA is pretty rigid, pretty strong. It just might be a bit brittle in some cases. You could give it a go. Now we're really hanging out. People keep joining, and I'm just like, this is the most nothing stream I've ever done. It feels weird not actually really doing anything on a live stream. Why do I bother doing anything on any other live stream? We still have 40 odd people. Referring to the what do I do for the next Smurf feeling? Oh, printer block printer. What is the... Oh, yes, I know. Yes, 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 yes. For everyone that's been joining in more recently, there is a BOM in a bill of materials, a list of all the parts required, and links in the description below. So it looks like this. Oh, you can't see that. Ta-da! Has all the parts, links for most of the things. As you can see, for fasteners, I just went with the local reseller option because that's what I recommend you do. As you can see, we use quite a few heatset inserts in this design. 228 M3 ones. Again, you could probably modify this to be less, but they're not that expensive really. So I think 100 is like £9. $210 M3x8 screws. Many, many screws. Millennium Machines. Trade you a Darwin Evo for a Millennium Mill. I don't have one yet. This is still the original. This one does not belong to me anymore. This one is for demonstration purposes only. I literally cannot print on it because the bed is a 110-volt bed now. The bed is not even plugged in. I've plugged in the thermistor so that it doesn't cause power off. But yes, it's a 110-volt bed, so I can't use it. It's a headache and I'm trying to do too much. That is the question. How do you stop yourself going too far down tangents and bringing things back to the original idea? Oh, I have no idea. If you work out, let me know. Oh dear. It's very, very difficult. It's very difficult to A, not take your project further down the line than you want to, onto a million different things, and also not to start other interesting projects when you come up with the ideas as you do them. At the moment, I am working on many, many more projects than I really have time for. I just try to work on what I enjoy the most and try and focus on making sure things get finished. I'm not great at organizing things, but as long as I keep working, things do get finished. So I think if it was a business with more people, they'd all find it very, very frustrating that the business has no real like target of this is what we're working on at the moment. But then again, if there were more people, you could say, well, you're going to work on this, and then they just work on that. But I don't know. I don't know really how on the casing, but a modern spin on the old replicator would probably make it look as well. Wasn't that one? Didn't Alan Mandic really did an old replicator, didn't he? I might be wrong. He definitely modernized an older printer. Great on the cauliflower. Thank you. 200 plus heat settings, it's like an hour of work. No, it's not that long. It's quite a while. It's quite a long build. There's quite a lot to do. It's yes. As I said, I'd recommend a heat set insert press. Obviously, I'd recommend specifically VLMP because it's mine. Set yourself feature limits. It helped me a lot. Feature creep is something that gets us all, and keeping them controlled is something that comes with time. Yeah. It is basically about setting objectives and hitting those objectives. And you have to be satisfied. Understanding what is good enough is also important. Like this printer is good enough. It's not 100% perfect. Anything you do will never be that. Like, don't target being 100% perfect because you will never finish a project. Sometimes good enough has to be good enough, if you see what I mean. It's better in many ways because nothing you make or design will be perfect, and nothing that's perfect will be perfect for everyone. It's best to get something done that works and is what you want it to be fundamentally, and then make improvements and iterations from there. Because as soon as you start getting feedback, if it's, I mean, I'm talking public projects and like sellable things here, really. But once you start getting feedback, that's when like you can work on focused things that people want and need. Before that, it's kind of just ideas, and you can have millions of great ideas. I'm sure everyone does. But ultimately, they might not actually be useful. But do you foresee as its greatest strengths and weaknesses? Mine are the machines. Its greatest strength is what it looks like, and its greatest weakness is what it looks like. Like the greatest thing about it is that it looks like the original Darwin. That was the main goal, and that was the one I focused on the whole time. Whatever I was doing, I was like, however cool we try and make it has to look like a Darwin. And inevitably, because that is the entire focus of the machine, we do sacrifice a little bit on performance. We sacrifice a little bit on cost, on building efficiency, on all these things, because the main purpose is to look like a Darwin. As maybe, if this is going to be like how I build printers at the moment, and if I develop it and we carry on doing designs like this over the next few years or whatever, then that'll be maybe where it starts to move a little bit away from what the original Darwin looks like, and we keep some of the fundamentals, but maybe speed up some of the assembly process and make some things a bit more integrated, or improve some of the ways to get the performance that we didn't have in the original. Everything you do is always out of date, so it can't be perfect. I'm not sure that's entirely true. I mean, when it comes to technology, it feels like things go out of date very fast. And I think as the designer of something, you will feel that more than anyone, because by the time you release a product and it's brand new for them, you might have already been working on it 2 years, at which point you might think, well, the technology's 2 years old, the product's 2 years old. This is an old thing and I'm literally just releasing it. So you'll probably feel that more than anyone as the designer. But time is not necessarily a problem. Like cauliflower is, I think, quite a good example where I've been working on that for a very, very long time. It's been released for like 2 years. And yet you bring one video along that reintroduces it to everyone, and suddenly everyone knows about it when they didn't before. The fact that it's 2 years old is irrelevant. Like, to everyone else, it's new because you've just found it. So like age, in terms of technology and like CPU power, yeah, it matters, because software and development and features and all this kind of stuff. It just is. But when it comes to hardware design, like hardware design doesn't really change. Not everything needs to be not everything needs to be based around the best performance or best price to performance. Sometimes the metric for a good project is just the enjoyment. Yep. Yeah, that's really what Darwin was all about. Lots of fun. And I think that's kind of what Milo is about as well, really, isn't it? I mean, it's a very good performing machine, actually, so it's kind of performance. But it's like, it's also a fun project, and I'm sure it has been for you as well, so... Ultimately, nothing will be perfect because that's just the way of life. Like, it won't be perfect because of timing. It won't be perfect because people want different things. It won't be perfect because manufacturing tolerance. There's no such thing as perfect. There is only good enough. You just have to decide for yourself what that is. And also considering that as the designer, again, you're probably the most critical of the things that you do. Like, you're intimately familiar, like, for this. So although this is like Darwin, it looks like Darwin and it's a Darwin Evo, none of it is actually the original design. I took every single part, I made little modifications, made a kind of general sketch of what I wanted, and redesigned the entire 3D printer from nothing. Every single part has been completely redrawn. So every single dimension of every single part has been implemented by me. I'm not trying to brag about the work that I did, but my point is you get an intimate familiarity with every single part because you see it in like every single detail. I didn't just go to an AI and go, build me a 3D printer and this is a picture of it. You don't get any understanding that way. But through doing every single part in every single detail, that you can't not know those things. They just happen. They're just in your brain. How do you keep costs in check when aiming for good enough? I think it's kind of a bit of a brute force method. But it comes down to kind of an engineering design practice of reduce the part count as much as possible. The fewer number of parts, the lower the cost will be. But also start with the cheapest and worst thing you possibly can. Because if you start with something expensive and then you test it and you go, it works, you're like, well, now if I want something cheaper, I have to test it again. Whereas you start with the cheapest thing, you can be pretty sure that the more expensive thing will work better or work similarly. But if you start with the very cheapest thing, you'll understand what the cheapest way to make this thing is. But yeah, trying to make something, the MVP, minimum viable product. It's generally a software thing, but yeah, it kind of applies or can apply in hardware too. Make the cheapest, shittiest version of the thing that you can. Get it to work, and then find out what breaks. Improve the thing that breaks. Keep improving the things that break until nothing breaks anymore. And that's the cheapest way to make it. It's not necessarily the fastest way, because you might have to do loads of testing, but that's the way you get into like actual like advanced engineering where you're doing simulations and stuff. So you can test all those things without having to actually buy them and make them, kind of thing. You do analysis to kind of create your decisions, to help you with decisions rather than just winging it. When you first showed Darwin in your channel, as you explained what was about as an enthusiast of 3D printing, I instantly desired to have one. Yes. Good. I'm happy to hear that. It's nice to hear people share the enthusiasm that I do for this project. Good evening, 3D Guster. Still nice to Darwin. Will always be, I think. Darwin is kind of a timeless design, especially for people that are kind of into that open source 3D printing. The worst thing about developing Reach alone is that you constantly see parts you modify a little. Yeah, how do we get around that? Again, it's about determining what's an improvement and what's required. If you assembled something and it works, you don't have to touch it. You don't have to change that again. Or if you've tested it and it works, let's go a little bit further. You could say in your mind, well, I want that to look a little bit different, or I think I could do this to improve that. It's like initial design process does not require improvement. It requires functionality and maybe, like, as I said, the MVP, the minimum viable product, not the most expensive viable product. When it comes to projects that you release to the public, can be hard sometimes because what you may release have some problems. So you've already fixed in the next version that isn't released. Yes, that is a difficult thing. That's just a time thing. I mean, I think the more you get into projects, it can be what drives you to make sure you do keep improving things, because you'll know that those little things that sort of annoy you as the designer are out there. And over time, people may come across them. The more people come across them, the more you'll want to fix them. But then that's kind of how businesses tend to roll forwards and improve their products over time. That's what everyone does. That's how they've released a new iPhone every year for the past whatever how many years. Because there's little things that you can change and improve, and new technology comes along and you make a new little addition. Is that Joseph's one? No. This is still the OG one. This is number one. It's just not been shipped yet. I know it's February now, so that was 2 months ago. But there's a box coming to me, a plastic box, a big plastic box. This will go in that plastic box, and then it will go over to America. The Joseph Prusa one will be live stream series. Yes, it's going to Ellie. Yeah. Joseph gets one as well. So Joseph's, yes, because he asked me specifically. So he's doing an equal donation. So we double the donation to the Sanjay Mortimer Foundation, and he's also paying for the whole thing to be done. So, yes. Yes, this is somebody else's now. This printer does not belong to me. Yep, that's... This is not my printer, but it's still in my house, so it's on the screen. Has anybody started purchasing parts? If you have any questions, like if you've got any specific BOM questions, now is the perfect time. Because once it gets more public release, I may not have as much time to answer every individual question. Many times it's aesthetic improvements that bother me, so I make a new version. The best thing for me is to share the file, then it's finished for me. Yeah, I mean, aesthetic improvements are a difficult thing. Again, you can't have a printer that's perfect in that way because it's subjective. Everybody's idea of what that thing would look like at its best is going to be different. You can obviously optimize what you think it should look like, but don't overstress it, because again, you're going to see the worst parts of its appearance, whereas everybody else is likely to see the best parts or not even care that much. Many times it's aesthetic. Oh, sorry, I just read that one. Nice to see the Darwin Evo next to the Mark 0 and Mark 1 at Prusa. Yes, I can't wait to. It'd be so cool. Yeah. I don't know. I'm assuming that's where it's going to end up. I don't know, but yeah, I assume, because I know they've got like a sort of museum bit, haven't they, of all the evolutions of the Prusa machines. So this one will sit right back at the start. Hopefully, that'll be cool. I mean, does it sit at the start or does it sit at the end? It was released after the Mark IV. And yet it's the oldest design here. It sits at both ends. Did you ever get set up with your workbench project? I may need a few soon. It's never been a product that I sell physically. I sell the digital design files. I don't know. It's a really difficult one. It's the development slowed down. Obviously, it's this behind me for anyone that doesn't know what we're talking about. Development on that project was very difficult because of space. Like, it's an enormous thing, and I can't just like lay it down because I just have no room in here to do things. So if I want to make modifications to it, it's just very difficult to do. I want to do more with it. I'm just not quite sure what to do. I have an enormous Excel calculator that basically creates the entire BOM of this design at any specification you like. But it's an absolutely mammoth Excel spreadsheet, and it'd be way too difficult for anyone to use, I think. There's just like little tick boxes for yes, I want this, no, I want this. You can say, oh, I want these joints, I want that joint. It does all your BOM and all your costs, it just adds everything up. But it just looks like a nightmare, and I couldn't get it to a place where I was happy with it, so I just not anything. The only thing that's available is the basic mill of materials for the basic designs, like the standardized design. And yeah, that was kind of it. It has so much potential. I still think it needs to be, yeah, it needs time. This is a problem with a lot of my projects. I get deviation. I start this, and then this new thing comes along, and then I get offered this thing, and then I want to try this thing, and then unfortunately for those, I wasn't necessarily getting paid straight away, so I got to go do this thing to get some money, and then I got to go and do that thing to do this, and then my brain's just like, oh, I'm just focused on this, and I can't sleep, so I go and work on that for a bit, and then everything just gets in a big muddle. So I just end up on a million projects at once. Yeah, I just find it very difficult to manage my own my own brain. Who has the original Darwin? The original one, well, I believe it's probably the one that I guess is the original, is in the Science Museum in London. So I visited when I was designing this kind of revised version. I was like, I can't trust these images on the internet. I don't know exactly when they're from or who actually made them or anything, or like what stage of build they're at. So I went to the Science Museum. I traveled all the way up to London to go look at this one 3D printer in the museum. And I took some pictures of it there. If you're ever in London, I'd recommend going to have a look. But probably don't make the whole travel just to look at that one 3D printer. How's the cauliflower going? Oh, cauliflower. Did it skyrocket after the video from Stefan? Yes, it's been very, very popular since then. I spent a few days helping people work out that maybe don't like reading instructions so much. But yeah, it's been very popular, and I'm really pleased to have lots of people using it more. So very happy with that. Joe to ask for the number of plates you're spinning. To be honest, I wouldn't even be able to count them because I never really know. I know it's too many, and I try and write things down. I try and keep my projects at least written down somewhere, so if I forget about them, I come back to this project sheet that has them at least in some sort of list, and I can recover where I was at. But prioritization of just different things just changes over time, or you find a deadline for something that you didn't know you had. Like this week could be a good example. Apparently, something I didn't realize until 2 days ago is that policies for sending emails from a website changed today, the 1st of February 2024. And the emails from my website were not necessarily 100% set up for that to be okay. So I could have been in a situation today where all emails from my website just failed to send completely. All just got sent to spam, or I got blocked or blacklisted as a result. I was just like, Well, I can't do anything else. I have to make sure that that works before today. So it's things like that, these little annoying business things. And the website takes a lot of time. I kind of want to move to a new platform that's a bit more managed. So I don't know how many of you have done website-y things. I'm not a great fan of them, but obviously I wanted to have a website. So I set up WooCommerce, but it's one of these, it's basically like a DIY 3D printer of websites. So you end up, you buy this thing, you buy this thing you buy like 20 different things from 20 different people, put them all together, and ta-da, there's your functioning website. And then you go, well, I want this feature and this feature and this feature, and you bung a bunch of plugins on top. And you just end up with a website that definitely works. I'm really happy with, like, generally that it works and it looks okay. But some of the things, like the layout is just not quite perfect. And if you change the sizing, like the picture change and the text doesn't, or the layout and the width just never looks quite right. So, yeah, I mean, yes, WooCommerce is based on WordPress. So it starts with WordPress, you put WooCommerce on top and a bunch of other plugins. And it's just plugins after plugins after plugins, all made by loads of different people. So kind of what I want to do is go to the, I don't know, the Prusa of websites, being like Shopify, where instead of going to 20 different people and buying 20 different services and trying to jam them together and keep them working, you just pay for one service and they do all the things. I might lose some functionality that might be nice to have in the long run, but the pain of constantly having to manage updates and installing new updates and subscribing to things, and like, it's just, you need a whole team to manage a WooCommerce site. Whereas I feel like with a Shopify thing, you could do it with one person. And for those I haven't noticed, I'm one person. Yes. Write things down. Did I say I write things down? Or maybe I do. Well, yeah, I write things down in two ways. Like on where I'm working, which is not this desk. This is just my live stream place. And I do like building and stuff here. But I work in the other room. And I always have piles of paper in front of me where I just take notes with a normal pen or pencil and just write stuff down. If I have a phone call, like, I write down what we're talking about. If I have a meeting, I write down the minutes, and it's all just in a pile of paper in front of me, which is kind of messy, but it's always there. And because I always work in the same place, it's always in front of me. So that, in terms of like having paper notes for like progress, I find really useful. But also the longer term things that if you put on paper, they end up getting damaged by the time you need them, or lost or whatever. I have, what's it called? Like Monday.com, I think it's called. Not a sponsor. Again, it just happens to be what I'm using. Which I'm not really using to its full potential, because I'm just using the free package. So it's basically not much more than a list that's semi-structured. I don't put deadlines or anything in, because that just, I hate the idea of deadlines. So yeah, I use that to kind of help me a little bit longer term plan what other projects could be coming up, the kind of things that I need to prepare for that project, and that sort of stuff. This chat got a little bit off topic, didn't it? This feels more like a members live stream, doesn't it? We've had loads of people just disappear, so maybe they got to go do something for 5:30. But I think we've hit, amazingly, like nearly 2 hours or something. Yes. I don't know how I've just sat here and talked for 2 hours, but that seems to have been what's happened. But I think it's probably time to sign off. Don't forget to check out the link down below. The official release will be tomorrow, and I'll announce it more then. But the link is available, it is live, and you can go start using it now. I will just clarify, that BOM is not fully tested, so it probably won't be perfect. But for those of you that build printers regularly, like the main parts are all there. It's just like, is the number of screws just right? Probably not perfect. If you're going to self-source, just buy a few extra of all the things. All the cheap things. Don't buy like extra beds, obviously. But yeah, if all the little stuff, you probably wouldn't be bad off to just buy a few extras, just in case I've counted something incorrectly or missed part of an assembly in my adding up. I've just noticed that the latency seems to be a lot more than it normally is, which is maybe why the conversation's been a bit delayed. It's been a bit weird. Normally, I thought the ultra low latency was only like a few seconds, but it seems to be like 10 at least. Right. Yes. Thanks everyone for tuning in, even though I just sat here and talked and didn't actually do anything. But it feels good. I'm happy that I'm slowly making good with my promise on open source. We've got STL files, full Fusion 360 CAD, and a bill of materials now. I can't remember if I uploaded firmware or not. I think I did. Maybe I didn't. Okay, I might not have done firmware. I'll do it at some point. Anyway. Wonderful. Thanks, everyone. Cheerio. I shall speak to you soon.